Howdy, everybody. Um, we're here doing some more Advent of code solving. Hopefully everything will look okay in the video. I had some issues with OBS, well, with Windows, and lost all my settings. One of these days I'll have some free time. I'll move back over to Linux. Anyway, we're here. Hopefully everything sounds okay and looks okay. I'll keep an eye on it, and if there's issues, I'll try and fix it. But we're solving day 5 today. And let me just say before we get started, as always, thank you for your messages. It's really cool to see some of your solutions and the way you're doing anything. There was a comment from the previous video, day 4, about using the matches. What do they call those? Function or whatever. And that was a really cool solution. So anyway, I think there's always cool things to do to optimize to make it look better, and it's cool to hear what you guys are doing. So with that, we'll just move on and start working on day 5. So this is, doesn't he have Intern-Elves for this? Santa needs help figuring out which strings in his text file are naughty and nice. A nice string is one with all of the following properties. It contains at least 3 vowels. It contains at least one letter that appears twice in a row, like XX. It does not contain the strings listed here, even if they are part of one of the other requirements. For example, this is a nice string because it has 3 vowels, a double letter, and none of the disallowed substrings. AAA is nice because it follows all the rules. This is naughty because it doesn't have any double letters. Yeah. This one is naughty because it has XY in it. And this one is naughty because it contains only one vowel. Yep, there you go. Okay. Oh, so this is just kind of like a pattern matching thing. You probably do some kind of regex with this pattern. I think that would work. One thing that's going through my mind, though, is like a potential solution is to use the Windows method against slices, because we're looking for double letters and we're looking for not these letters. So like these, well, I'll show you in a second, but what the Windows allows you to do is create little blocks of a slice that you can like slowly work your way through. And so as we're doing that, we just count the vowels, and then we count the, we check if there's a double, and then we check if we've seen one of these. And if we're okay, we get them, we check them all. I did look at the puzzle input briefly, but I didn't know exactly what the problem was. So like, here's the puzzle again. Okay, so there's only like 1,000 of them, so it doesn't feel like you probably solve this anyway, and any way you wanted to, and you'd be okay. But let's just try the Windows one. So we'll say like let p1 equal 0, and we'll like say for in input dot lines. So we're just going to go through all the lines, and we want to create windows for of 2. So the way that works, let's change this to line. So we'll say for window in line.win. It's called windows, right? What is line? Is it a string? It is. So we want to create a windows of size 2. So just like what did I do there is the lines was just returning a string, but we want to get windows of each of the 2 characters. So I just mapped each of the lines to the vector of characters. So now each line is, instead of being a string, is a vec of characters. And now I can iterate over each 2 chunks. So it's going to start like over here. It will do ZG and then GS and then SN. So we can do something like let mute vowels equals 0. Then we'll say if window. We'll only check the last one. Like if we notice, if we check the first, we won't hit the end. Ooh, but how do we do that? We want to know how many vowels we've seen. But as we're going through the windows, it's going to do this, then 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 this. Let's just look and see. I'm trying to think in my mind how we want to do the vowels. The other 2 are probably easier. We can, let's while I'm thinking about the vowels. So we don't want to contain these ones. Are they going to look like that? Something like that. So if bad contains window, we return, or we can, we'll continue outer. Like that. Okay, what doesn't it like? Mismatched types. Expected found. That. Okay, well, I mean, we can just go, we can just do it like this. Like that. Okay, so that, like, that's the bad one. I think what we're saying is like go through all the windows, and if we ever see one of these, so if the bad list contains this current window, then we want to continue in the outer, right? What was the other issue? We wanted to see if a double was found, right? Twice in a row, one letter twice in a row. So if they're the same, then we'll set twice equal to true. So after we've gone through it, we can say if vowels greater than 3 and twice, P1 is incremented. Okay, so now we just got to figure out the vowels thing. Like, what's going through my mind is like, how do we, and maybe it's probably just easier just to like go through it a second time. You know, part of me is like, oh, can I be really cool and just go through it one time with like this Windows? But you could argue I've already like collected here, so it's not as fast. We can do refinements later. I mean, so what would it look like if we just counted them? We just do like line dot um maybe like map. Actually, I can just do like this, right? Something like that. Okay, so the quickest fix is just to do this. So what is this? What are we doing here then? We're saying check to see if there's vowels through an iter. And then go through the windows and see if we find any bad ones right here, or if we've seen two in a row. And so if we ever find a bad one, we know we can just quit. If we ever find a double, we set this to true. And then at the end, after we've gone through the whole thing, we always have to go through the whole thing because we need to check for bads. But after we've gone through the whole thing, if we find 3 vowels, is it greater than or equal to? Oops, I did that the wrong way. Right? If it contains at least 3. Yeah. Okay, so we can do their tests maybe just to double check. test all these, see. So if we do their test cases, there's 1, 2 are nice. We expect it to only be 2. It doesn't like, I can't remember. I'll just do unwrap. Okay. First time every time. 238. We got it. Okay, there's part 1. Part 2, realizing the error of his ways, Santa has switched to a better model of determining whether a string is naughty or nice. None of the old rules apply, as they are all clearly ridiculous. Okay. Now, a nice string is one with all of the following properties. It contains a pair of any 2 letters that appear at least twice in the string without overlapping. It contains a pair of any 2 letters that appear at least twice in the string without overlapping, like XX or XY, XY, or AAA, but not like AAA. It contains at least 1 letter which repeats with exactly 1 letter between them, like XYX. So the X's are repeating. And then this one's EFE. So right here, EFE or even AAA. And then it gives some examples. It's nice because QJ is in there twice. ZXZ is right here. This is nice because it's got double X's. And then it's got XYX. This one's naughty because TG repeats, but never ABA or ZXZ type thing. This one is naughty because it has a repeating letter with one between. Okay, so this one doesn't have, oh, it has ODO, but there's no like repetition in it. Okay, so let's just start by writing these tests. I hate the wiggly lines. I should probably just turn off spell checking. So this one, this one, this one, and this one. And we expect to get is nice because it had, so 1, 2 are nice and 2 are naughty. So we still expect it to return 2. Okay, what's changed here? We can still use the windows for this part. Because you can do windows of 3 and then you look for XYX. I'm trying to think of how you do this. You may just have to recursively test. So here's the problem. like this case right here, if you're doing windows of 2, like you had, like this one's okay, but then this one's not. Presumably these would always, in this method, it'd always have to be the same. There might be a way to kind of figure this out. You are doing, in this one, you're doing windows of 2. In this one, you're doing windows of 3. Well, let's just try programming it and start. This one, I feel like what you probably want to do is like start at some position and then take the 2, see if you can't find that in the rest of the string, and then do that recursively. We'll see if there's a better, we can talk, well, let's talk about optimization later, right? So we'll probably do the same thing that we did here though in P1. So I'm going to start with this. We'll call it P2. And we are going to still loop through all the lines. I guess a lot of this stuff goes away. But we can still do like what are these called? So we'll just like let mute repeat equals false. And then we'll do like for window in three if window 0 equals window 1, no, window 2. Like that. So that's this first case. No, that's this second case. That one's pretty easy. So for this one, I think what I do is I just start at some n. So we'll just be counting. What's happening here? So we'll say like, I think it's -4. Like because you'd never find one at the end. Like if you were on these last 3 characters and you hadn't found one yet, there's no way you're going to find it here. Let me show you what I'm thinking and maybe we'll see if that's right. So we'll say let search equal line I and line I plus 1. For j in I plus 2 to line dot lane -2 if So I'm thinking like this, like that. So what are we doing? We're going to go through the windows of 3, and if we find one, we return true for the repeat and we break. Then if we're going to look for all the doubles, and I think this is right. Like basically what we're going to do is say, go through all but the last 4. And then we're going to search. The search is going to be our current position and our current position 1. And then we're going to loop through the rest of the string. And we're going to say, hey, give me those 2. And if that's equal to what I'm searching for, then I'm done and I can break through. I mean, I think that will work, if that makes sense what I'm doing. Like, so the first thing I'm going to do this Z and G. And then I'm going to start right here and then just start going. Can I find a ZG anywhere else in here? Right? Let's try this in the unit tests. No. 41. Where did I blow up? Test P2. Left is 0, right is 2. Oh. Hopefully it's just that. Had the wrong day. Nope. Still bad. It only finds 1. So why were these okay? The pair is QJ and it's QJ. This is nice because it's got XYX and then it's got XXXX. Ooh, it could be. Could be these right here. I think this one's still right. But let's try it like that. There we go. Yeah, so what was... sometimes I forget this, but this doesn't include that number. Anyway. This one we still want it to be 4, I think, though, because we want to go back. -1. -1, 2, 3, 4. Actually, I think this is 3 as well. Yeah, I think it is 3. The thing to remember is that when you're doing these iterators with the countings right here, like with the ranges, it doesn't include, like, it's inclusive of this, but it's exclusive of this number. So you'd normally just do line.len, and that would get you this number, but we want to go 3, 1, 2, 3 back from that. Like, this would be the last one we'd want to check. And the same thing with right here. Okay, so then we can, let's just see if it works. 69. Nice. That's the right now. Okay, very good. Again, this wasn't too hard. I mean, I probably made it harder than I should. I should add that I'm sick. So does that count? Does that help? I didn't solve it very well. But again, the goal was just like doing some string parsing and manipulation. This solves so fast, right? Like we can add, I probably ought to just do this by default. Maybe I'll work on that. Is it not instant? Oh, it's instant. That's what I was doing wrong. So we're just testing the time. How long does it take to solve these? These are like solving in microseconds. So you could probably do optimizations. We could probably clean up the code a little bit too, but these are there's just so few. There's only 1,000 of them, right? And the strings are relatively small. I don't think there's anything you could do to optimize it. But it would be worth looking into, like, could we make it cleaner? Like, for example, I know a lot of people don't like these continue to the outer. This is just like a shortcut, right? It's like we know if we've ever found a bad one, there's no way this string is okay, so we're just going to skip past it. Like we could actually remove this down here too. So we could say something like we can still do it like this, but we can say like if vowels less than 3 continue. Like that. These two are kind of happening at the same time. In the windows. We still have to go through them all because we had to check for any bads. Like what was going through my mind is it possible to like do the twice? Like if we already get the twice, we break out, but we still got to check the rest for bad. We could make this more functional, and maybe that would make it cleaner. That is to say, we could like what we've done here, we could do for the other ones, and maybe this looks cleaner. So check for bad pairs, and then we could say like let found equal line dot windows to dot I mean, it would just be the same as down there, right? W0. Oops, I got that wrong. W1. Oh, it's not filter. We just say any. Like that. We can look and see, and then we just do the same thing. Check for two of same adjacent. So let found equal in dot windows 2 dot any w0 equals w1. Like that. So the idea here is we are iterating through it multiple times, but again, it's so small that maybe this is like more readable. We'll see how bad it changes the counting. But basically, we're looking for any vowels, and then we're going through windows of 2 and saying, are any of them bad? And then we're going windows of 2 and saying, are any of them equal? If any of them are bad, we continue. If we got down here and we found at least one that has a match, then we know it's past all of them and we can test it. So presumably we get the same answer. 238, is that what we had before? Yeah. Yeah, I mean, it's potentially slower sometimes, but it's probably well within the range of like normal. Again, it's just so small that it's hard to say that any single optimization. If these strings were like super long, absurdly long, and there were millions of them, I think you could make a case for saying how much of this can we do in a single loop or in a single pass through. And maybe you even say, I'm not even going to convert them to a vec. I'm just going to, check. I can do windows. I think there's a way to do windows on strings. Something probably to ask the AI about. We can do that. It's only such as the or that on a string you convert to slice first. So here they've done it like this. Here they've done it as bytes. Oh, okay. I mean, if you knew it was single characters, you could do it as bytes because it was ASCII. Okay, I mean, yeah, that works. That might be an optimization you could do here. Again, they're so small, it's hard to say that it's going to help any. But let's look at part 2. Is there a way to make this look a little bit better? I mean, you could probably follow the same pattern right up here. So we could say like let mute, or we could say let repeat equal line dot windows 3 dot any So like that, I mean, that does feel cleaner, right? You're saying, hey, find all the windows, and are there any where the first and the latter are the same? Did I say that right? Look in the windows of 3 and see, can you find any of the first and latter are the same? This one is one I'd really like to think about, because like, here's what it'd be almost nice if you could just like break them into like chunks and test them. But like, imagine the, like, you couldn't break it into like a like, say you had the string a b b a. You could argue that, oh, if I break it on these boundaries right here, then I can check, are there any doubles? But that doesn't work for like a b a, or like even their test was, what was it, xxyxx. Like, that doesn't work. Like, you almost just want to do like a, string contains or whatever. So like, the search is the first two. You're always going to search the first two, and then you're just going to say, can I find that in the rest of the string? Which is like what's happening here, but it doesn't look great. So I'm just gonna stare at this for a few seconds. Maybe it's obvious to you if you have some better way of solving this, or something that at least looks more elegant. These feel elegant. This feels elegant and fast enough to solve the problem, right? The same with up here, right? Like, I could show this in a video and it would be clear like what I'm doing to solve the problem. This one definitely feels like that. I don't know why, but for this one, it doesn't really feel like that. It doesn't feel obvious, right? So maybe we could just ask the AI. I have a vec car, and I want to find any two pairs of non-overlapping cars that are the same. So is bad, but is good. And the string could be fairly long. So let's just see what it says. Hash maps. You can use a hash map to track all the pairs and their starting indices, then check for any pairs that appear at least twice with non-overlapping indices. So here's their solution. Oh, that's interesting. I mean, the hash map does work. But it is giving me an idea, right? Is like you can see what they're doing there is like they're adding indices and they're looking for it. I mean, this isn't the perfect way to do it, but they're like saying, "Oh, can I find? I'm going to look for pairs, and I'm going to add the pairs in the thing." Um, and then you can kind of look and say, now that I now have a hash map that has doubles, so I just need to know, do those doubles overlap? And that's what it's doing here, which doesn't feel totally. I mean, maybe this is a clean way to do it. It looks like it works, but it's occurring to me like you could also do this with collect all the windows. It may not be faster, but my thinking is like collect all the windows, and you do this partition thing where you say like, okay, grab the first window. I know the next window can't match. Now am I in the rest of the window? Um, you're still n squared, right? Your big O n squared, because you're looping through it. For each window, you're checking every other window. It's like n squared over 2 or whatever, right? But it's essentially n squared. Whereas this one is n times k, where k is the number of pairs. Again, this is so small, I don't think it matters. Sorry, I know I'm blanking out occasionally. Like I said, I'm not feeling well, so maybe that's an excuse. But maybe I don't talk enough in my videos anyway. But I'm just trying to think that through. Like, what is the better way to do this? Let me show you what I'm thinking. Like in my mind, like obviously this still works. But if we say like let windows equal line dot windows 2 dot collect. I actually don't even know what this is, but it's something like that, right? Oh, I'm missing one of these. Okay, we could just do vec. What did it say it was? We're gonna have like a vec of There's no way it likes. Oh, okay. I mean, that's fine. So we have these windows, and then we say like for so for window in windows dot leader. We need to enumerate. If windows. Okay, so we have the ith one. If windows I plus 2 dot contains window. P2 plus equals 1 break. What doesn't it like about this? Windows is a vec car, so presumably this is a pointer to a car. Can I just do like this? So this is going to give me an oh, I know what it's like this. Right? So like give me a piece of it. It's going to be something like that. I mean, I think this works. Let's try it. 69? Yeah, got it. It does appear, well, it's probably within tolerances. Okay, so what is this doing? And again, it's not really like, it doesn't feel like it's I don't know. It does feel a little bit more readable than this. You collect all the windows, and then for each window, you're going to say, are there any windows after me and my previous one or my next one, right? So I want to skip my next one as well. That's why I do the I plus 2 here. So I say, hey, are there any of these that are the same as this one? And if it is, I continue. Again, I don't know which one's better or slower. I'll probably keep them both in just so you can see, but I'd love to see your solutions. So there you go. There's probably me well overanalyzing a problem that's not too hard to AOC 215 day 5. So I'll submit a gist of mine and you can use it and play with it. and show me how you changed it. That's what I'd really love to see, is like, what did you do differently? Because, you know, you can see here there's definitely multiple ways of solving these problems. I'm just curious what everyone else did, more ways, more interesting ways to solve it. I'm familiar with Windows, and so that's kind of what led me down this path. I think these windows are really cool ways of like iterating over things. And you can see like up here is where it feels like really good, right? These two feel very readable, right? You obviously have to know what windows are and like what this ini is, but it felt really clean. So, and maybe I'm over, like if I was in C, right, we wouldn't have these windows. I would just be like recursively checking, I think, right? Which is essentially what we were doing down here, right? We find the first two characters and then we go see through the rest of the array, excluding those two. Can I find it? That's what this does here in less code, but it's essentially the same and probably not as performant, right? Because now we're collecting these windows. But anyway, there you go. Bye, everybody. Hope you're doing well wherever, whenever you are. And we'll see you next time.